Let's look at an application of an ellipse. In this situation, or in this problem here, we're looking at engineers are trying to design a new train tunnel, and the shape of this tunnel is supposed to be a semi-ellipse. So semi-ellipse just means it's half of an ellipse. And the plans are that they want to make the tunnel 12 feet wide along the bottom of the tunnel, along the ground, and it should be 15 feet tall at the center. So let's try to draw what this tunnel looks like again. We're going to draw a horizontal line and then kind of an arch over it. Okay. Now, we could do a similar problem where this arch was a parabola. So we'd have more of a parabolic shape. In this case, it's going to be an ellipse, though. Okay. So it's a half of an ellipse. So you could technically think of this ellipse extending downwards below that horizontal line, but we're not worried too much about that part. What we do know is that the whole tunnel on the bottom is 12 feet wide. And I know from the bottom to the top, to the very top, is 15 feet. Okay. So I have kind of this picture drawn, but I need to relate what it looks like to an ellipse equation. And an ellipse equation needs to have x and y values. I need to know where the center is. And so I need to take the picture I've drawn and sort of place it on the XY plane. I need to know where's the origin, where's the X and Y axes. Okay. There's a lot of ways that we could do that, but usually the easiest place is to put the center of the ellipse at the origin. Okay. So the center of the ellipse, remember this ellipse extends above the ground, but because in the ellipse, it also extends below the ground. So the center of the ellipse is where it's going to be in the middle of that 12-foot section, the bottom of the semi-ellipse. That's actually the middle of the graph. And then it's going to be where that horizontal line of 12 feet intersects the vertical line of 15 feet. Okay. So that's where I'm going to place the origin. Okay. From the origin, so from the middle of the graph, the tunnel is 15 feet tall. So that's from the center to the top of the graph. It would also be from the center to the bottom of the graph too, if we drew the full ellipse. And I know the total width is 12 feet. So if it's 12 feet wide total, that means from one side to the middle, from either side to the middle, would be a distance of 6 feet. Okay. So from the center to the top is 15 feet. From the center to either side is only 6 feet. So because this ellipse is taller than it is wide, I'm going to write an ellipse where the A value is underneath the Y. Okay, so this is an ellipse that is vertical. Okay, so a vertical ellipse, and it's centered at the origin. A vertical ellipse would have the form x squared over b squared plus y squared over a squared, and that's equal to 1. Okay, and again, I don't need the h and the k because they're both zeros, since I put the origin at the center, or the center at the origin. To write the equation of the ellipse, I just need to know my a and my b value, which we actually already know. The a value is the longer distance from the center to the outermost point on the graph. And so in that case, the A has to be 15 feet. B is the shortest distance, which is 6. So I already know the A and the B value. A is 15, B is 6. So my equation is going to be x squared over 36 plus y squared over 225. And all of that is equal to 1. So that is the equation that describes the full ellipse. Now, technically, we're doing a semi-ellipse, so I'm only going to use the top half of that equation, but that's the ellipse. That's the equation of the ellipse that we want. Okay, so the second part of this question is, what is the height of the tunnel 1 foot from the side? So if we thought of where this endpoint is on the right side, and you can do the left side too, it doesn't matter. It's a symmetric shape. If we looked at that endpoint on the right, we want to come in 1 foot. So if that's a 1 foot, what is the x and the y coordinate for that point corresponding on the ellipse? Okay, so if we come in 1 foot from the outside corner, from the outside edge, what is the height of the tunnel? So that's the vertical dimension. Well, if we're coming in 1 foot from the side, how far are we from the center? Because remember, the center is at the origin. So if the whole width from center to the outside point is 6 feet, then that means from the center to that 1 foot in mark is actually 5 feet. Okay, and then we want to figure out the height. So the x coordinate for this point on the ellipse is 5 for the x, because it's 5 feet from the center and 1 foot from the outside, 5 feet from the center, and the y value is what we need to figure out. Once we know the y value, that answers our question. Okay, so we're just going to take the 5 and plug it in for x, and we'll leave the y in there, and we're going to solve this equation for y. So we're going to take the x squared over 36 plus y squared over 225. We're going to plug in 5 for x. So we're going to have 5 squared over 36 is equal to, plus y squared over 225, and that has to equal 1. 5 squared is 25, so we have 25 over 36 plus y squared over 225 is equal to 1. This is just an algebraic equation. We just need to solve it for y. So to isolate y, let's subtract the 25 over 36 to the other side. Y squared over 225 is going to equal 1 minus 25 over 36, which to subtract a whole number and a fraction, you need a common denominator, which is going to be 36. So 36 over 36 minus 25 over 36. 36 minus 25 would be 11. So we have 11 over 36, and that equals y squared over 225. To isolate the I, you multiply the 225 over. So y squared is equal to 11 times 225 divided by 36. And to find y, you just take the square root of that. So the y is equal to the square root of 11 times 225 over 36. And again, we could try and simplify that, but let's just go ahead and go straight to technology here. And so if we compute that with our calculator, the square root of 11 times 225 divided by 36, we will end up getting a value of approximately 8.29. Okay, so if we move in 1 foot from the side of the ellipse, that's 5 feet from the center, then the tunnel will be a height of 8.29 feet.